What's up, math fans? Today is Sweater Vest Fridays. If you ever catch me wearing this sweater vest again on a Friday, I will send you a free calculator. Offer does not include Monday, Tuesday, Wednesday, or Thursday sweater vest. Alright, we're moving on to plotting linear equations using the slope intercept. And I talked about the word slope and I talked about the word intercept already, so that's review. And I will review, don't worry. Here's some skills that you might need. In my old videos, I addressed all these skills. See if you find my video on plotting points. That was my very last video. See if you find my video on literal equations. You'll see why you need literal equations here, which is kind of weird. But math is like a big puzzle. Algebra is like a big puzzle. And every piece is addressed in a separate video. But then as we go deeper into the curriculum, all of those pieces come together in one big problem. And you also need to know how to graph linear equations using the solutions. So basically, actually, these two skills were addressed in my last video. You need to know how to plot a point. So if I say a point, real quick, we'll go here. Let's say I say plot the point 2, 3, 2 comma 3. Remember this? 2 comma 3. 2 is the x value, 3 is the y value, x is this axis, y is this axis, y to the sky. So 2 comma 3 would be right here. 2 comma 3. You gotta know how to plot a point. Otherwise, review that. And in that same video, I showed you how to graph linear equations using the solutions. Meaning, I gave you an equation like this, and then we made a table of possible solutions, and we discussed that there's infinite amount of solutions. So we just graphed a few, and then we created this line, which is a representation of all solutions. The table kind of looked like this. It said x, then I wrote the equation in the middle, and then I had y, and then I had x comma y. Now I'm just going to put x and y next to each other, and I'm going to do it in my head. If x was 0, I plugged in 0 for x. 2 times 0 is 0 plus 1. Y equals 0 plus 1 is 1, so y equals 1. If x is 1, 2 times 1 is 2 plus 1 is 3. So y equals 3. If x is 2, 2 times 2 is 4 plus 1 is 5. If x is 3, 2 times 3 is 6 plus 1 is 7. And you kind of get the idea. And then I said, you know it's linear because it increases by a constant rate of change. That's important. Constant rate of change. Goes up by 2. From here to here. Goes up by 2. From here to here. Goes up by 2. All right? It keeps increasing by a constant rate of change, which is 2. 2, is that coincidence? I don't think so. It's not a coincidence. Your rate of change is this number, also known as the slope. Slope, using slope. So we will be using this number. It's very important. And this number 1, well, it's always 0 comma something. It's always 0 comma this number, the starting point. This is known as the starting point or the y-intercept. Slope intercept, all right? So here my slope is this number, and my intercept is that number. That's my slope and my intercept. So when you're looking at something that looks like this, y equals something x plus something, that is the slope-intercept form. You always want y equals something x plus something. And most math teachers use mx plus b. Calculator uses ax plus b. Same thing. M is the slope. And b is the y-intercept. Okay, intercept. It's where the line crosses the y-axis. You want more details on this? I gave you a story in my last video when I was using the solutions to plot. I talked about what the slope meant, it's the rate of change, and what the y-intercept or the starting point is. So now, I no longer need to make a table. For one reason is because the graphing calculator does the table for you. If you use the y equals button, you press y equals 2x plus 1, and then you press second. Look, that's not going to work for us. Let's use a better marker. Second, and then graph. That actually gives you a table of values, of x and y values like I just had. All right? That's only if you are so inclined to use this. So I would turn it on. On is here, okay? I would press y equals, and I'd show you the screen, but that's a waste. This is not a technology class. I'm trying to teach you how to do it without technology. So I don't need this, all right? That's just for cheaters. By the way, TI-84 graphing calculator, guys, send me a check for promoting, thanks. All right, so let's say I have no graphing calculator. All I have is this equation, which happens to be in standard form. I'm gonna start from the y-intercept, which is 1. Put a point on 1, right here. How come I put the point on that one instead of this one? Because it's called a y-intercept. Y-axis is here, put the point on 1. On the line, not off the line, not floating in space. Right on the line, starting point. Then, I go 2. What does that mean, 2? It means, it's almost like the last story I told you when I made $10 an hour. That means my line goes up 10 and over 1. This is 2, so my line's gonna go up 2 and over 1. How do you know it goes over 1? Well, this m I said was slope. Slope is rise over run. So slope is rise over run, and this 2 should be a fraction. It's 2 over something. In 3rd grade, they taught you that any whole number can be put over 1. All right? Once you remember that, you start at 1, and then you do what the slope tells you to do. Go up 2 and over 1. Rise, run. I rise, I run. I rise, I run. Think about when you're sleeping. First you have to rise, then you run. You can't just run out of bed. You gotta rise first. I'll do it again. Now I'm here at this new point. I rise 2 and run 1. So from 0, 1, I'm at 1, 3. Now I'm at 2. And I might be a little off. 1, 3 is here. 2, 5 is here. And those are all the points that were just on that table that I erased. Just for fun, I'll go one more time. I rise 2 over 1. I should be at 3, 7. Wasn't that another point on the table? So I didn't even need the table. Rise, run. Do that a couple of times. Connect the dots. And extend your line. That's how you graph a line. The end. You're welcome. That's how you graph a line that is in slope-intercept form. And if you remember my last video, I said, even though you start from 1 and you go in the positive direction, if it's not a word problem, negative numbers do exist. The line goes both ways. All these negative solutions also exist. Okay? Done. Thanks a lot for checking it out. But if you're curious to know what you do when the equation is not in slope-intercept form, because slope-intercept form should be y equals mx plus b, where y is alone. Well, good thing you're good at literal equations. You know how to get y alone. If y is not alone, what do? Well, let's see. How do I get y alone if there's a 2 there? There's a coefficient there. I got to get rid of the coefficient. I divide by 2. I divide by 2. If you divide by 2 in one spot on an equation, you have to do it in every single spot or every term. So I'm not going to show it like this. I'm actually going to be specific and show it like this. Divide by 2 and divide by 2. 2's cross out. Y equals 3x over 2 minus 8 divided by 2 is 4. So now it's in the form y equals mx plus b. But the plus b, it can be minus b. It can be a negative. All that means is instead of starting from up, you start from down. Instead of starting from 4, I start from negative 4. So I'm going to go 1, 2, 3, 4, and I start here. Here's my starting point because my b is negative 4. Okay? What's my m? A lot of people will say 3x or 3. It's not 3x and it's not 3. M is the number or coefficient of x. In this case, it's 3/2. And that's even better because I taught you that it's rise over run. So I rise 3 and then I run 2. Rise, then run. So I'm going to rise 3. 1, 2, 3. Run 2. 1, 2. I'm here. For this, you should have graph paper. You'll see it perfectly.